So pilots and others who encounter UAPs often state that their abrupt high-speed maneuvers appear to be way beyond our physics. Is that a reasonable conclusion?
When you hear that, that sounds very reasonable. I mean, after all, you've got pilots observing these craft coming from space, dropping down to the Earth within a few seconds, and then stopping on a dime, and then suddenly taking off at high Mach numbers and doing a right angle turn. So it's very reasonable. It's a natural thing for these pilots to say, this is just way beyond our physics. On the other hand, I approached it as a scientist in a different way, and I said, okay, if something is happening, it's got to somehow be part of our physics. So what I did was I took a piece of paper and I made a list on the left-hand side. What were the bizarre things that were being observed? Right angle turns at Mach 10, um, you know, diving into the water with no splashes, all the weird, walking up to a craft that seemed small, but they got inside and it was giant, things that, now for me, the more weird those descriptions, the better I like them. Because if somebody is just making up a story, they want it to sound kind of rational and reasonable. Well, my list of weird descriptions were not rational or reasonable. They're all off the wall. I then took general relativity and said, okay, in all of our ordinary electromagnetic applications with computers and Wi-Fi and so on, we start out with a series of Maxwell's equations and outcome all the predictions, and we do our technology developments. In general relativity, Einstein's theory of general relativity, now that's used primarily for investigating astrophysical phenomena like mergers of black holes and neutron stars and so on. So I said to myself, suppose we could engineer Einstein's equations for general relativity the way we engineer Maxwell's equations for all of our electromagnetic effects. What would I expect to see? And so I made up a list on the right-hand side of the piece of paper, and they matched hand in glove with the weird observations being given on the left-hand side. Let me give you an example. For example, let's say, okay, you've got this thing going at right angle turns at Mach 10. If anybody were in there, they'd be turned into tomato sauce in the back of the ship. But anyway, when I apply the equations for general relativity affects time and space variables. So it turns out that one of the consequences in this case is that time runs faster inside the craft when it's engineered the way I'm proposing. And so for them, they're just taking a leisurely turn. Of course, when they look outside and see all of us on the ground, we all seem to be going in slow motion. But anyway, what appears to be an absolute unbelievably right-hand turn at Mach 10, for the people on the craft, that's not the case. Similarly, in reports of people approaching a craft, which is some particular size, and then when they get really close, the craft seems either much larger or much smaller. These are the kinds of things that general relativity would predict. Another example would be time running at different rates, so that if somebody supposedly has been taken aboard a craft and they're in there for a while and they come out and they find time has gone by much faster outside or at a different clip, and they think, well, maybe I've got missing time or whatever. Anyway, you go down this list of weird things, but they do match up with general relativity. Okay, so if we physicists know how it's working on the principle of general relativity, then why aren't we building them? Why aren't they aircraft? Well, it turns out that the one requirement that is a real challenge is you have to have enormous amounts of energy collected in very tiny volumes, extreme energy densities, and we can't do that. That's where we fall short. So I would say the physics is straightforward. It is within the physics that we know, but it's way beyond what we can do with our engineering.